All right, hello everybody. Welcome to today's virtual lesson. We'll be learning about molecular geometry. I'm going to share my screen and we will get started. All right, so I'm Austin Curtis presenting on molecular geometry. So we'll start with what we know so far. So we've learned a lot about electrons, how they exist in atoms, usually in the same amount as protons, and that they drive the bonding. We know about Lewis structures, we've started drawing those. We know about the bonding patterns, we've learned about things like carbon and nitrogen and how many bonds they make. We know about valence electrons and how that drives the bonding. And then we know that lone pairs come into play when we need to fill shells. Then we got into VSEPR, so we've learned about the repulsion of electrons from each other in domains. We'll get a little bit more into these in a second. So when we talk about drawing Lewis structures, we know most atoms want 8 valence electrons, although hydrogen only wants 2. The valence electrons determine how we draw the Lewis structures. You start with a center atom, continue until you've filled 8, and then make sure you add lone pairs if necessary. Make sure all valence electrons are present. So we've done all of that so far. This is just a little background reminder. We've talked about VSEPR, so electrons want to be as far away from each other as possible. So think about when you tie 3 balloons together, for example, they'll be about 120 degrees from each other, right? They'll repel as far away from possible. So thinking about these repulsions will help us with the geometry, which we'll get into today. So where we go from there, we'll think about molecular bonding. We'll think about the types of shapes that molecules make. So we get into linear, bent, trigonal planar, tetrahedral, and trigonal pyramidal. Those are the only 5 we will cover in class today, but there are more molecular shapes that can occur. So a quick overview looking at these shapes, we can get them from the total groups of electrons. We get to our hybridization based on the electrons. Think about our bond angles, the number of bonding electrons, lone pairs, geometry name, the shape, and some examples. So this is a table you can use as kind of a reference for studying. So let's dig in. So think about a simple molecule that you know. We all know what water is, H2O. If you draw the Lewis structure for this, look at the electron domains, think about the shape it would make, we would call that bent. So hydrogen, 2 of them bonded to oxygen, water, would have 2 lone pairs, making a bent shape. So that is important for when hydrogen or for when water molecules bond to other water molecules. This bent shape can create interactions, but we won't talk about that too much today. So we'll start with our simplest shape. So the most simple thing you can make is a linear molecule because it is simply 180 degrees from each other. So there's only 2 electron domains in this case. And in nature, when you have 2 electron domains like this, the easiest way to get them as far away from each other as possible is 180-degree angle. Think about when you want to be as far away from another person, you just stand straight across from them. You don't want to rotate around and stand next to them. You want to get as far away from as possible. VSEPR helps us with that. So an example of this is CO2. Now there are lone pairs on the oxygens here, but they're not on the center atom, so that doesn't matter. And it's okay that there are double bonds because this counts as 1 electron domain as a double bond. So carbon here has 2 electron domains that repel as far away from each other as possible. So what if there are 3? Then it can be trigonal planar or bent. And that depends on if there are double bonds or not. So trigonal planar, we have 3 atoms bonded to the central atom. So this would be 120 degrees. So think about BF3, which breaks the octet rule at boron, but the bond angles still hold and the shape is still trigonal planar. So if you have a center atom, 3 electron domains, all of them atoms, you'll have trigonal planar. To contrast, 3 electron domains, one of them a lone pair, so we have the double bonds coming into play here, that would make a bent shape. So this would be like SO2, where there's one lone pair. This would make about a 109.5 degree angle. So why would it not be 180? Well, the electron domain pushes these away. That still counts as one of our domains. It has a say in that making that of that angle. Why would it not be 120? Well, the electron, the lone pairs, actually have a stronger force than the double bond, pushing them away even further, so that the angle between the double bonds would be less than 120. What about if there are 4 electron domains? You can make 3 different shapes depending on lone pairs. You have tetrahedral if there are 4 atoms, trigonal pyramidal if there are 3, and you can have bent again if you have 2. Think about, or looking at this top right picture, the lone pairs help us think about a tetrahedral shape, but it does end up just being bent because we just look at the atoms. We'll get more into these in a second. So tetrahedral, easiest way to get 4 atoms all the way apart would be in this 109.5 degree angles. So think about pyramids that you might come across in nature, the Great Pyramids of Giza, for example, right? That's an example of something you might see. So it's maximizing the space between the atoms like CH4 here. Trigonal pyramidal has a lone pair on the top. So the lone pair again pushes away a little bit further, so our angle is less than for the tetrahedral. You got 107-ish. So an NH3 would be an example. Then we get into bent, where there are 2 lone pairs pushing even further. So we're likely even less than 107. So the lone pairs have a bigger push than our single bonds. So it's essentially the same shape as the other bent, but with that angle decreasing a little bit more. So I guess you could say this is the shape of water. So let's practice now. So identifying the shapes of these 6 molecules. So we have NO3, HCl, SCl2, CF4. Then we have an ion, we have H3O+, and we have ozone, O3. So let's start with NO3, 3 electron domains, a double bond here. What shape should this make? Should make trigonal planar. Yeah, so 3 domains, no lone pairs. Good job. Then SCl2 would be bent because we have the 2 lone pairs. And how about the next one? This would be trigonal pyramidal because of that lone pair at the top. And how about ozone? That would be bent. CF4, this should be tetrahedral. And HCl, just 2 atoms bonded together, the only shape that can make is linear. So practicing with these 6 molecules gets us to these different types of shapes. Now it's your turn. So take the quiz in the Google form link provided. Take your time and think about the shapes that will be made. Good luck.